All right. Here we're saying let z equal 1 plus 3i, represent z and each of the following on the same Argand diagram, and comment on their relative positions to z. So I think the easiest way to do this is let's do the algebra first, then we'll plot them and then talk about their relative positions. Okay, so A, 2 times z is going to be 2 times 1 plus 3i, and that just becomes 2 plus 6i. My conjugate of z is 1 plus 3i conjugated, which becomes 1 minus 3i. I times z becomes I times 1 plus 3i, which becomes I plus 3i squared. And we know that I squared is equal to negative 1. So that becomes negative 3 plus I. Negative z is just going to be negative 1 plus 3i, so it becomes negative 1 minus 3i, and then I squared z over 2, I squared z over 2 is going to be I squared times 1 plus 3i over 2, and we know that I squared is equal to negative 1. So we get negative 1 minus 3i over 2, so it's negative a half minus 3i over 2. All right, let's have a look at sketching each of these things. Let's sketch z first, and I reckon I'm going to sketch that in green so that we can see it. So 1 plus 3i. So we're starting at the origin. We're going to go across positive 1 and 3. So that is where z is sitting. All right, let's do all the others in red. So 2z is 2 plus 6i. So I go across 2 and up to 6. So 2z is over here. And, oh, it's in the same direction, but it's twice as large. So same direction as z, but twice the magnitude. Okay, let's look at the complex conjugate of z. So that's 1 minus 3i. So if I go, that means I'm going to go positive 1 and minus 3. So my conjugate of z is going in the negative direction, okay, for my imaginary axis. So it is reflected about my real axis, but my magnitude is the same. So same magnitude, but reflected in the real axis. Okay, let's have a look at I times z. Well, I times z is negative 3 plus I, so I'm going to go negative 3 plus 1i. And this is going to be iz. Now notice that, I wonder what color would be a good color to do. My original complex number z was over there, and what I have when I multiply it by I is I have a rotation of 90 degrees anti-clockwise from Z. Okay, remember that clockwise is always going to be positive. Okay, so I've got the same magnitude. But it's rotated 90 degrees clockwise from Z. Okay, now if I have got negative Z, well, that's negative 1 minus 3i. So let's go, we go negative 1 minus 3i, and that's sitting over there. So negative Z. Well, I have changed the direction, completely the opposite direction. So both my real and my imaginary components are negated. So that means I've got the same magnitude, but opposite direction. All right, and then I squared Z over 2. So if what was I squared Z over 2? Negative a half minus 3 over 2i. So, well, that's going to be really small on here. Negative a half minus 1.5i, somewhere over there. And that is my I squared Z over 2. Okay, and basically it's going in the opposite direction. So it's the same as multiplying by negative 1. But it is half the length. So opposite direction, but half the magnitude.